Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain Lab. And what I've got today is a Dana Model 5900. It's called a 5 3/4 digit um, voltmeter. It has digital multimeter capability with upgrades. So the panel shows that you can get AC and ohms as well. However, this is the base unit. The base model comes with the DC only. Um, by the appropriate boards, you can expand this unit to handle more. So the manual that will come with it on CD will take you through that and explain how you can upgrade it. But for now, we're interested in the voltmeter part of it. It's a 5 3/4 digit voltmeter, like I mentioned. What this means is that under certain circumstances, you can read up to 6 digits, 6 decimal places, and and they talk about a 3/4, but technically, in my mind, that doesn't make sense because they claim that it means it's limited to the first 2 digits reading no more than 0.16. Um, and 3/4 would be 0.75, so it doesn't read up to 0.1.75. So I guess it's probably an advertising thing. They didn't want to say 1 and 3/5 or something like that. Anyway, um, if you were reading on the 0.1 volt scale, you could get 6 full digits. You'd read right down to the microvolt and up to 0.16 volts. And then every time you increment the dial for another decade, you slide your decimal point from the left figure over to the right, and you limit the number of decimal places that you have available to the right then. So right now I am in the 1 volt scale, so I have 6 decimals, 1, 2, 3, 4, 5, 6, but I've slid my decimal point over, so I have 5 decimal places to the right, 1 to the left. And as I go to the 10, I have 4 to the right, 2 to the left, and so on. 3 to the right, 3 to the left, 2 to the right, 4 to the left. It's a very nice looking unit. It's in good shape. Nice wire stand. Nice big bright digits. I'm very impressed with that. My eyesight is not what it used to be, and I do appreciate a big digit. So let's see, we're going to open it up and give you a look on the inside. Give me a moment. Okay, we've opened the Dana up, and we get a look at its sophistication. It's a very sophisticated instrument. This is late 70s, early 80s kind of vintage to my mind. I see a capacitor that's reading 75 over here. So quite possibly 1975, 76, somewhere in there. Anyway, and then this large shielded area here, if you can read it, that says basic DC calibration, and it gives you the calibration steps. Input shorted on the 0.1 volt DC range, adjust the front panel DC offset. And it takes you right through the calibration. This is excellent because with all of the access holes all clearly marked and available from here, as long as you have a DC input that's stable and of that voltage, and our voltages would be 0.1, 10, 100, and 1000 to do a full calibration. If you can give those voltages steadily, then you can calibrate this unit and keep it in tip-top shape without additional cost. So we're going to put the cover back on it, let it heat up a little bit, and then we're going to run it through its paces. So bear with me, and we'll do the testing. Thank you. Okay, we're putting in a zero point 0.1 volt signal, and as we can see, the two units are reading within a microvolt of each other, and most often reading with each other exactly in 6 decimal places. So we're reading to within a microvolt of each other, perfectly in sync. Let's go ahead and raise the voltage. Okay, we have 0.15 volts. This would be near the max end of its range, and again we see that we're within a microvolt of each other. And this would be the max end of the range, 0.15 and 0.16 to all effects, but 1.5 in all nines, 8 or 9, they're both flashing together. So we're reading and resolving the 0.16 volts very, very closely, right down to the microvolt. Let's go ahead and change the range. Okay, we're reading 1.6 volts on both meters, and as you can see, we are in agreement to all 6 digits. We have 5 digits to the right, 5 decimal places, and we are reading the same voltage, 1.549. Okay, we've switched to the 1 volt scale on the Dana, and we see that in both cases we're reading 0.1. In the Hewlett-Packard we've got 4 zeros and a 5, and on the Dana we got 3 zeros and a 1, which would make sense if I was to reduce the range on the Hewlett-Packard to the same number of decimal places. Then we see that we are reading within 10 microvolts of each other. Sometimes reading exactly the same. There's a little flashing going on. 0.1 zeros on the Hewlett-Packard, 0.1301 on the Dana. Let's go to the other end of its scale here. Okay, we're reading 1.5000. Let's expand our scale on the Hewlett-Packard. Okay, I see 1.5 and 4 zeros on the Hewlett-Packard. I see 1.53 zeros and a 1 on the Dana. So to the last digit we are one digit off between the two. Let's change our range to the 10 volt scale. And so we have 1 and 4 decimal places on both units. 1.40, 1.40. So we're reading a volt on the 10 volt scale perfectly. Let's raise ourselves to 10. Okay, we're at 10 volts now, and we see that both units are reading 10 and either 4 zeros or 3 zeros and a 1. They would be in agreement at 3 zeros and a 1. We get a little flashing there, but they're right on. And let's take ourselves up to the end of the scale. $15, 3 zeros and a 2, both units. Okay. Let's go to the 100 volt scale, and we'll take our 5 back down to 0 just so we can get a look at the low end. 100 volt scale, we're reading 10, and we have 3 decimal places on both units. 10.000 both units. Now let's take ourselves up to 100. And we'll increase our number of decimal places on the Hewlett-Packard. And we see at 100 volts, with this input, we're getting 100.002 on both. Okay. And if we take ourselves up to the end of the scale, about 150, that would be, give ourselves a little bit more range here. 150.004 on both. Okay, let's go to the 1000. Now here we're going to get a little, this is a little worrisome, but I don't like playing around with the 1000 volts much. Take ourselves down. Okay, we're reading 100 volts on both units. 100.00 both units. And let's take ourselves up. Okay, there's 900. And we are within 1/100th of a volt of each other at 900 volts. And finally, we're going to go to 1000. This is the limit of both meters. I don't want to go any higher. We are within 1/100th of a volt at 1000 volts. And at on the 1000 volt range, at 1 volt, we're reading 1.00 on the Dana, and we got 1.0000 on the Hewlett-Packard. So that gives us a walk through all of the ranges, and we see that the results were extremely good. We have a nice looking unit. It's performing well. It will come with a CD manual, both the user and service for the Dana, and gives you instructions on also implementing any future upgrades. So thank you for listening and giving it consideration. Happy bidding on the unit, and we'll see you again. Bye.